Land use systems are complex adaptive systems, and there are many types of changes in land use systems. For example, a land use system can change from producing for food to producing for bioenergy. And the land use system can change from crops to dairy farms. And the land use system can also change due to population change. For example, rural depopulation might result in rural land abandonment. I study land use change by looking at land use systems as complex adaptive systems, so I make models. In making those models, I take into account interactions between land users and all kinds of interactions and feedbacks they receive via different factors that they are involved in. I use agent-based model to study land use change because of the following factors. First, agent-based model allows for the representation of heterogeneity among the agent populations. Second, because agent-based model is process-based, it allows for the representation of feedbacks so that different influences from the subsystems such as the market, the environment, the policy institutions can play a role in determining the behaviors of the land users. And lastly, agent-based models allows me to explore the assumptions on the social behaviors of the agents. For example, how does interactions among farmers, such as peer pressure and social norms, can affect their behaviors of using their land. This would be very important and helpful to study the nonlinear changes in land use systems. With more and more processes taken into account in my model, the model becomes more complex. Hopefully, with the sensitivity analysis, I can have a systematic overview of the behavior of the model and the system so that we can find tipping points in different regimes of land use systems. With the knowledge on the regime shifts and tipping points in land use systems, we can provide policy recommendations to policymakers so that certain desired land use transitions can be promoted and some other undesired land use transitions can be avoided.